All right, so let's take a look at these examples of operations on functions. So in this one, we have two functions. We have function f and we have function g, and they're given up at the top here. And it says find the function values if possible. And so this example is done for you. This is the sum of function f and g. And so you'll see here they say take the function f and evaluate it at 4 and take function g and evaluate it at 4. This is the input for both of them. And so in the beginning here, at the beginning, we have 4 squared plus 9. And function f is you take the input, you square it, add 9. So that's this part. And then here we have function g, which is you take the input, square it, plus 2 times the input minus 8. And so that's what you have here. So now doing the calculations, we end up with 41 once we add it all together. In the next example, again, done for us, here we have f divided by g of 3. So this means that we're going to take function f, evaluate it at 3, divide by whatever g of 3 is. So this notation here tells me to take f of x and divide by g of x. And so you'll see inputting 3 into f, inputting 3 into g, and then evaluate each of those separately and then divide the final, or leave it in this fraction form. Now, this next one, this one is a composition. And so that little circle that you see there, that means composite. That it looks like the word fog, but this right here is the composite function. And with composite functions, you always work from the inside out. So they rewrite it, instead of f composite g, they put f of g of -1. So these two things mean the same thing. This is just written with that composite symbolism. So whenever you have these composite functions, you work from the inside out. So we're going to work first and evaluate what g at -1 is. So work from the inside out, evaluate g at -1. G of -1 would give me -9. So now that I found this portion, so I'm only doing this inside first, now I take that and I put it in place of that portion. So you'll see here, now you're going to evaluate f at -9. So evaluating f at -9, now I'm going to go to function f. Function f, if I scroll back up, is x squared plus 9. So I'll take -9, square it, plus 9. Remember, when you square a negative value, it becomes positive. 81 plus 9 is 90. So my overall answer would be 90. So let's try it with these. So you should pause the video. You can try these, and then you can watch how I complete them. So here we have function f and function g. For this one, it says take f plus g at 5. Well, that's going to mean here's my input. This notation here means I'm adding the two functions together. I can write it like this and figure out what that is first, or I could do this. I can take f, evaluate it at 5, and add g, evaluated at 5. So here, let me put that in a different color. So for function f, I will refer back to this right here, and I'm going to take, and I'll put blank spots wherever I would have an x. And then in place of x, I'm going to plug in 5. And then I'm going to take function f, or I'm sorry, g, which was x squared minus 1. And I'm going to put blank spots in for f, or for, sorry, for x, I keep saying f, for x, and I'm going to put in 5 wherever there was an x. So 5 is my input. And so now evaluating this, I would get 25. 5 squared is 25. Minus 2 times 5 is 10. Plus 3 plus 25 minus 1. So now I'm going to add, and this will be subtract 10. Well, that's going to be 15. Add 3. Well, that would give me 18. And then I'm going to add 25 and then subtract 1. So let's say 18 plus 25. Well, that's 43, and then subtract 1, and overall I get 42. So the answer you should have got for part A is 42. Now the next one, we have this f divided by g. So that means it's division. And my input here is -2. So I'm going to work on the top and I'll work on the bottom. For f, this is function f. And what I like to do is put those blank spots in there. And this is function g. And now I'm going to input my input. I'm going to place my input in those blank spots. So my input is -2. Now I have to keep in mind that when I have -2 squared, it is the whole thing squared. So it's going to be positive. -2 squared means -2 times -2. If I just put this in my calculator, the calculator is going to return -4. You have to make sure you put in the parentheses because it's that whole thing that's squared, not just the 2. So we'll end up with 4 plus 3 in the numerator, and in the denominator 4 minus 1. So in the numerator I end up with 11, and in the denominator 3. So my answer here, you should have got 11 over 3. All right, let's try the last two on this page. These two are, well, C is a composite function. It's taking the function f and doing a composition on itself. So I'm going to rewrite this in that from this composite notation with that, but instead like this. And now I'll work from the inside out. So I'm going to first evaluate this portion. Well, that portion, let's do it over on the side here. F at -1, function f was x squared minus 2 times x plus 3. So I'm going to plug in my input of -1, and let's evaluate it. Let's see, what do we get? We get 1 plus 2 plus 3. This 2 is positive because multiplying a -2 by a -1 becomes positive. So you end up with 6. So that replaces this highlighted portion. So working from the inside out. Now it's saying take the function and evaluate it at 6 because we found out that f at -1 is 6. So f at 6, again, I'm going to put my blank spots in and now plug in my input of 6. And let's now calculate that. We get 36 minus 12 plus 3, and that would give me a 24 plus 3, or 27. So for letter C, you should have got 27. And then the last one on this page is F this is not the composite function. It's f times g at 0. So that means f at 0 times g at 0. So I'm going to plug in an input of 0. So I'll plug in 0 into the f function. Let's do that now. Function f looked like this. It's the x squared minus 2 times x plus 3. So I'm putting, that is the function f. And the function g was x squared minus 1. So here let's input 0 into function f, and let's input 0 into function g. So evaluating this, for this part here, in this first part, well, I have 0 squared minus 0. 2 times 0 is 0, plus 3, so I get 3. And the second part, I'll have 0 minus 0 squared, which is 0, minus 1, so I'll get negative 1. 3 times negative 1 is negative 3. So these are the 4 answers we should have got for the end of 8.1.